Something is wrong with the Earth's core, and nobody would have expected what scientists have now discovered down there. Could it even have something to do with the impending pole shift? You can find out all about it in this video, so be sure to watch to the end so that the YouTube algorithm shows this important topic to even more people. Thank you, friends, and welcome. The Earth's magnetic field is going crazy. The sun is approaching its solar maximum, and now there's also the bizarre behavior of the Earth's core. Quite a lot going on. But first things first, it all started in 2019 when Chinese forecasters from Wuhan measured very strange values in the Earth's core. They found that there is a fluctuation that occurs about every 8.5 years, and that could be described as core wobble. I don't know about you, but Asian researchers sensing a strange steady tremor from the Earth's core sounds to me like we're about to have a rendezvous with Godzilla. The Earth consists of 3 main layers: the crust, the mantle, and the core. These layers vary in density and have different chemical and physical properties, which are influenced by geological processes such as plate tectonics and volcanism. The Earth's core is the innermost layer, which consists of iron and nickel and has a comfortable temperature of around 5,500 degrees. The core is divided into 2 parts: the outer core and the inner core. The outer core is about 2,300 kilometers thick and liquid, while the inner core is solid and only 1,200 kilometers in diameter. This hot, dense sphere plays a crucial role in generating the geomagnetic field that protects us from harmful radiation from space. This is known as the geodynamo, and I find it incredibly fascinating that the Earth's magnetic field in space is a product of the processes in the Earth's interior. Everything is somehow connected. You could almost get spiritual about it.
Everything is one, and we are all children of nature.
Or something like that. Well, previous models assumed that the Earth's core rotates along the same axis as the Earth's mantle, as both layers should have an even density distribution. But now we have to throw out all these ideas about the Earth's interior, because what the Chinese researchers have discovered is quite revolutionary. By precisely mapping tiny changes in the Earth's rotation, they made a groundbreaking discovery. The Earth's core could actually be at an angle to the mantle. In fact, the Earth's core has an inclination of 0.7 degrees to the mantle. Hao Ding, one of the leading scientists behind the new research, explains, the results of the Earth's free vibration indicate that the density structures inside the Earth are highly heterogeneous. So the assumption of uniform density distribution should not be realistic. Density structures are therefore very different from what we thought, and the relationship between the Earth's core and mantle must therefore be completely rewritten. And we remember, since the magnetic field originates from this interaction, this could also have strong implications for it. One of the most exciting conclusions from the research work is the assumption that the Earth's inner core is denser and heavier in the northwestern hemisphere than in other regions. And it is this asymmetrical distribution of density and mass that could explain why the Earth's core seems to wobble every 8.5 years. Ding says, this implies a differential rotation angle of the inner core of less than 1 degree to the east, and a misalignment of the symmetry axes of the boundary layer between the lower mantle core and the upper mantle. And this has really stark implications for numerous other processes on Earth. Let's take the Earth's axis, for example. If the Earth's core actually wobbles every 8.5 years, and this wobble is accompanied by an inclination of the core to the mantle, this could have an impact on the stability of the Earth's axis. A change in the tilt of the Earth's core could theoretically lead to a change in the tilt of the Earth's axis over time. The Earth's axis moves back and forth within a year anyway, namely by around 10 centimeters. This effect is called true polar drift. It is therefore normal for the Earth's axis to move a little. Over longer periods of time, it is also influenced by the attraction of the moon and sun, which is known as precession. In recent years, however, the Earth's axis has also been behaving in a super steady manner. Since the mid-1990s, its drift movement has changed immensely, shifting around 10 degrees to the east. Scientists have been pretty clueless so far, but maybe the new research is the missing piece of the puzzle, and the movement of the Earth's axis is due to the curious processes in the Earth's interior, who knows? With all this perplexity, it has to be said that the Earth's interior is not necessarily, brace yourselves, a core competence for researchers. And then, of course, there's the potential impact on the Earth's magnetic field. As we already know, the Earth's magnetic field is mainly generated by the dynamo-like process in the outer liquid core of our planet, which is driven by the movements of the liquid metal. And we also know that this magnetic field is of crucial importance for life on Earth, as it protects us from harmful radiation from space and shields the atmosphere from the solar wind. If the Earth's core wobbles every 8.5 years, possibly even changing the density or mass distribution in the core, this could obviously have consequences for the currents in the liquid core, and thus directly influence the dynamo process and the Earth's magnetic field. One possible effect could be a change in the strength or direction of the magnetic field. If the flow in the liquid core changes due to the wobble, the properties of the magnetic field generated could also change, and this in turn could affect the navigation of animals, the operation of electronic devices, and the propagation of cosmic rays. In addition, the wobbling of the Earth's core could also lead to instability in the magnetic field. An irregular or unstable magnetic field would then amplify the effects of geomagnetic storms, disrupt communication and navigation systems, and endanger the sensitive electronic devices on board satellites. Of course, we are still in the realm of absolute speculation here. We will now have to investigate further what this new finding means for the Earth's magnetic field. I could imagine that these new properties of the Earth's core at least play a role in the strange behavior of the magnetic field in recent years. As a reminder, the migration of the magnetic North Pole has become more and more pronounced in recent years. Here you can see its migration over the last few decades, which scientists interpret as the magnetic field becoming more fragile and approaching a pole shift. A magnetic anomaly has also developed over the southern hemisphere, the so-called South Atlantic anomaly, a weak spot in the magnetic field that is becoming increasingly massive. These are all signs that indicate that the magnetic North and South poles are preparing to swap places, and perhaps one piece of this geomagnetic puzzle is the rhythmic wobbling of the Earth's core. As soon as we have any new findings or anything else happens with the Earth's magnetic field, I'll keep you up to date straight away, I promise. But that's only possible if you follow my channel. I know from the YouTube statistics that more than half of the viewers haven't subscribed at all, but it's absolutely free. You'll never miss another galactic video, and you'll help me immensely. So everyone, press the subscribe button. Thank you so much. And it's not just the Earth's magnetic field that's going crazy, but also the ozone layer. A gigantic hole in the ozone layer has formed over the Antarctic, and it has something to do with the spectacular eruption of the underwater volcano Hunga Tonga. You can find out what this means for us in the video below. There's also some incredible footage of the volcanic eruption. Be sure to click on it, and if you want to support my work, be sure to visit my Astro store again. Otherwise, I'll see you in the next video. Take care, friends.